Alrighty, welcome back, ladies and gentlemen. We're going to be solving inequalities some more. Here we're going to solve 2-step and 3-step inequalities. And before we do that, we want to talk about a little bit of multi-step equations, the 2- and 3-step variety, just to help drive home what we've done in the past. Alright, so first one, 6x minus 7 equals 17. And hopefully you look at that and immediately think, hey, let's add 7 to both sides. And I'm sure you were thinking that. I know you. Alright, and then of course 17 and 7 is 24. At this point, of course, we're divided by 6, and we get a nice pretty x equals 4, so woohoo! Alright, remember these icky fraction kind of ones. When you have a great big fraction like this, you have to get rid of the number on the bottom first. So multiply by the 4, and then those cancel out, because technically it's a 4 over 1, and you can cancel anything with the top and the bottom. Alright, so you have just the x plus 9 left over. 8 times 4 is 32. And then from here, we just have a simple subtraction to cancel out the 9. 32 minus 9 is 23. Alrighty, hopefully that went, oh yeah, I know that. Alrighty, now once we get to the variables on both sides variety, okay, we do have some choices to make. Remember, we can either cancel the 2x first, cancel the 14, cancel the 5x, or cancel the 22, negative 22 technically. Alright, and it just depends on what you want to do. I'm going to go cancel the positive 2x first by doing a minus 2x. Again, this may not have been your choice, and if you wanted to do a different way, that's fine. Please do that different way, and we should get the same answer at the end. So I'm going to bring down my 14. This is going to give me a 3x minus 22. Now again, based on my choice, I'm pretty much locked into adding 22 to both sides here. If you made a different choice, you're locked into a different thing to do right now. So I've got 36 equals 3x, and at this point I'm going to divide by 3. You may be dividing by negative 3 depending on the choices you made, but regardless of what we did, we should both be getting to x equals 12. Okay, if you didn't get to x equals 12, then something went wrong somewhere else. But there you go. Okay, now let's get to the solving inequalities. Now remember, this works basically the same as solving equations, but we got to watch out for multiplying and dividing both sides by a negative. But we want to write our answers with a variable on the left, so if you made some choices to put your variable on the right, we just want to make sure we switch it around to get things on the left. It just looks nicer that way. Alright, so here we go. We've got 7x plus 4 greater than negative 10. Okay, just like if that was an equal sign right here, okay, hopefully you look at that and think, hey, I should be subtracting 4 from both sides, and you'd be 100% correct. Okay, now again, that greater than sign, remember, works just like a separator, if that works for you, just like the equal sign does. But whatever the case, so I've canceled the 4 both on the left and the right side of my divider, if you will. So now I have the 7x all by itself. I still have my greater than sign. Now this gives me a negative 14. Okay, and again, now I'm dividing by 7. Okay, I've got negative 14 divided by 7, so hopefully you're deciding whether or not to flip the inequality sign. Hopefully you decided not to. Okay, so we divided by a positive, so we don't flip the inequality sign. If the number we're dividing by is negative, then we flip it around. So you do have to be very careful about that. So please don't make that mistake. In this case, we should have x greater than negative 2. Alright, let's take a look at 2 more examples. Okay, first of which here, we got one of those fraction-y kind of guys again. So x minus 5 over 7 greater than 3. And again, that 7 is trapping the x minus 5. So we need to multiply both sides by 7. Now I'm going to go 7 over 1 on the left, just so it's easier to see the canceling of the fraction versus the whole number sort of thing. On the right hand side, I'm not going to bother writing it as a fraction because there's no fractions here at all, and I think it just makes it look messy. But anyway, 3 times 7 is 21. And remember, the whole point of doing this is all we have left is the x minus 5, leaving us with a relatively simple looking inequality in this case. Adding 5 to both sides, and just getting that letter by himself. So canceling that guy out, we got the x left over. I've still got a greater than sign, and that's a 26. And I certainly didn't do anything here that makes me want to reverse the inequality sign, so no big deal. Moving on to the second guy here. Okay, again, I've only got the x in one spot, so it's just a matter of canceling the 5 and the 23. Alright, so again, hopefully you look at that and think, okay, let's cancel the 23 first. So there you go. Now be careful here, as the 23's cancel on the left, I'm bringing down a negative 5x. And hopefully me saying the word negative there helped a couple bells and whistles go off in your head. But anyway, bring down my inequality sign. 98 minus 23 is a positive 75. Okay, now at this point, I'm dividing. Now notice that I'm dividing by a negative 5. Since I divided by a negative 5, I do need to reverse my inequality. So before I do anything else, just to make sure I don't forget, I'm going to take this guy and switch him around from a greater than or equal to sign into a less than or equal to sign. I meant to change colors there. Let's make it look all pretty. Woohoo, look at that. Worthy of writing home about, right? Okay, so anyway, there we go. So now it's a less than or equal to, notice the change. So I have the x, and now 75 divided by negative 5 is negative 15. Okay, again, hopefully that highlight shows up well enough. But again, divided by negative, so we reverse the inequality sign. And that's, again, the only thing you really have to watch out for other than the regular things we do with equations. Alright, well, as the words right there on the screen say, with variables on both sides, your choices about solving may determine how many times you flip the inequality around, or, quite honestly, when you flip the inequality sign around. Alright, so here's a couple examples, or really one example that we're going to do twice. Alright, I got variables on both sides, so again, I have 4 different choices I can make about who to cancel first. Although what I'm going to go for is the variables first, so that I'm only going to do this thing twice. Here we go. Alright, so first thing first, maybe your first thought is to cancel the 3x because he's smaller than the 8. Alright, so boom, cancel those guys out. We're left with a 21 greater than or equal to 5x plus 56. Okay, now again, remember at that point I'm pretty much locked into subtracting the 56 from both sides. Alright, so the 56 is canceled, leaving me with a 5x. And again, the inequality sign, nothing's been causing me to reverse that yet, and this gives me a negative 35 when I put these two guys together. Okay, now at this point, excuse me, I'm dividing through by 5, and it leaves me with, see, negative 35 divided by 5. Okay, and again, I didn't divide by a negative, so I don't reverse the inequality sign, but I do get a negative 7. And then the 5's cancel, leaving with an x. But yeah, now my variable's on the right, so that's awkward. So I'm going to put the x on the left, the negative 7 on the right, but again, make sure, you know, Pac-Man or the alligator, however you like to think of it, is eating the right number. But x is on the small side, negative 7's on the big side, so when you rewrite it, make sure it looks like that as well. So x less than or equal to negative 7. Alright, if we make different choices here, we shouldn't get a different answer, but we should have a different sequence of steps that takes us there. Okay, for instance, maybe you always like canceling the guy on the right, and I think that's a pretty good way of doing things as well. Again, not my way, but that doesn't mean it's bad. Here we go. So I get a negative 5x, I get a plus 21, greater than or equal to, again, those guys canceled, and I'm just left with a positive 56. Okay, at this point, I'm locked into canceling the 21. Remember the last problem, the last way I worked it out, I was locked into the 56 as my second step. Here I'm locked into the 21. Okay, so I have a minus 5x at this point. Again, I still didn't divide or multiply both sides by a negative, even though I did use kind of a negative here. It doesn't cause me to reverse the inequality sign since it wasn't multiply or divide. Okay, here this gives me a positive 35. Alright, now at this point, I'm getting rid of that negative 5 attached to the x, so I'm dividing by negative 5, so those cancel. But again, since I divided, this causes me to reverse my inequality sign around. So I have an x, and I have a negative 7, and notice I did get the same answer. It was just a slightly different sequence of steps that took me from the beginning to the end. So again, just pay attention to the steps you take and make sure you reverse things when you need to reverse them. Alright, well, as per usual, here's a few problems to try on your own, and as always, we'll open up class talking about these. Thanks a lot, and we'll see you there.